Our eyes, often called the windows to the soul, are also our windows to the world. They allow us to perceive the beauty of a sunset, the intricate details of a flower, and the expressions on a loved one's face. Sight is a gift that many of us take for granted, yet the mechanisms behind it are incredibly complex and fascinating. From the moment we open our eyes each morning, we are bombarded with visual information. Light bounces off objects and enters our eyes, triggering a chain reaction of events that ultimately result in our brains forming images. This intricate process involves not just the eye itself, but also the optic nerve, which carries signals to the brain, and the visual cortex, where these signals are interpreted. But how much do we really understand about this remarkable sense? The human eye is a marvel of biological engineering, capable of distinguishing millions of colors and perceiving objects both near and far. It adapts to changing light conditions, allowing us to see in both bright sunlight and dim moonlight. In this exploration of the human eye, we'll delve into the science behind how we see, uncovering the mysteries of this vital sense. We'll journey from the outer layers of the eye to the light-sensitive cells at its core, understanding how light is captured, focused, and transformed into the images we perceive. Imagine the human eye as a finely tuned camera capturing the world around us in vivid detail. The first point of contact for light entering the eye is the cornea, a transparent dome that acts like a window, shielding the eye and helping to focus light. Behind the cornea lies the iris, the colored part of the eye that controls the size of the pupil. The pupil, a black dot at the center of the iris, is actually an opening that regulates the amount of light entering the eye. In bright light, the pupil constricts, reducing the amount of light entering. In dim conditions, it dilates, allowing more light in to improve vision. This dynamic adjustment ensures optimal image quality in varying light levels. After passing through the pupil, light encounters the lens, a transparent, flexible structure located behind the iris. The lens further focuses the light onto the retina, a light-sensitive layer lining the back of the eye. The retina is often compared to the film in a camera, as it's here that light is converted into electrical signals that the brain can understand. These signals travel from the retina to the brain via the optic nerve, a bundle of nerve fibers that transmits visual information. The brain then processes these signals, interpreting them to create the images we see. This complex interplay of structures within the eye highlights the remarkable coordination required for vision to occur. Have you ever wondered why the world appears seamless, despite the fact that our eyes are constantly moving? The answer lies in the way our brains process visual information. We don't see the world in a continuous stream, but rather in a series of still images or frames, much like a movie. These frames are processed so rapidly that our brains stitch them together, creating the illusion of smooth, continuous motion. However, this system has its limitations. If an object moves too fast, our brains may not be able to process the individual frames quickly enough, resulting in a blurred image. This phenomenon is evident when we try to follow the rapid wing beats of a hummingbird or a bee. These tiny creatures flap their wings at incredible speeds, up to 80 times per second for hummingbirds, and an astounding 230 beats per second for bees. Our eyes simply cannot keep up with this speed, and the rapid movements blend together, appearing as a blur. This limitation in our visual processing highlights the incredible agility and speed of these creatures. It also underscores the fact that our perception of the world is not always an accurate representation of reality. Our brains constantly work to make sense of the information our senses provide, filling in gaps and creating a cohesive visual experience. Let's retrace the path of light as it enters the eye and gets transformed into the images we see. The journey begins with the cornea, the eye's clear outer layer. The cornea plays a crucial role in vision, acting as the eye's primary lens. It bends, or refracts, incoming light, directing it towards the pupil and lens. The amount of light entering the eye is regulated by the iris, the colored part of the eye that surrounds the pupil. The iris acts like a diaphragm in a camera, adjusting the size of the pupil in response to changes in light levels. This ensures that the optimal amount of light reaches the retina, preventing overexposure or underexposure. Once light passes through the pupil, it reaches the lens, a transparent, biconvex structure situated behind the iris. The lens further focuses the light onto the retina, ensuring a sharp image. Unlike the cornea, which has a fixed shape, the lens is flexible and can change its curvature to focus on objects at varying distances. This process, known as accommodation, allows us to see clearly, both up close and at a distance. When we look at a nearby object, the ciliary muscles surrounding the lens contract, causing the lens to become thicker and rounder, increasing its focusing power. Conversely, when we focus on distant objects, the ciliary muscles relax, allowing the lens to flatten, reducing its focusing power. Now, let's delve into the fascinating role of the lens in our eyes. You see, the lens is crucial for focusing light onto the retina, which is the light-sensitive layer at the back of the eye. It works much like the lens of a camera, adjusting its shape to ensure that we see clearly at various distances. This process is known as accommodation. Without the lens's ability to change shape, our vision would be blurry and unfocused. It's quite amazing how this tiny, transparent structure can make such a significant difference in how we perceive the world around us. So, next time you marvel at a beautiful landscape or read a book, remember the incredible work your lens is doing to make it all possible. Refractive errors are the most common vision problems. They occur when the shape of the eye prevents light from focusing directly on the retina. The main types include myopia, or nearsightedness, hyperopia, or farsightedness, and astigmatism, which causes blurred vision at all distances. Corrective lenses or refractive surgery can often help. Substances like alcohol and certain medications can affect vision. Alcohol can lead to temporary blurred vision and slower pupil reactions. Some medications may cause dry eyes or sensitivity to light. It's important to be aware of these potential side effects and discuss them with your healthcare provider. A balanced diet plays a crucial role in maintaining eye health. Nutrients like omega-3 fatty acids, lutein, zinc, and vitamin C and E can help prevent age-related vision problems such as macular degeneration and cataracts. Eating a variety of fruits, vegetables, and fish can provide these essential nutrients. Protecting our eyes is vital. Wearing sunglasses that block ultraviolet rays, using safety eyewear during activities that could cause injury, and taking regular breaks from screen time can all help maintain eye health. Regular eye exams are also essential for detecting problems early and keeping our vision sharp. Remember, our eyes are a precious gift, and taking care of them is a lifelong commitment. Hit that like and subscribe button, all you science enthusiasts, and check for a new video about science every day. See you later in the next video, and have an awesome scientific day.